Let's move on to the next subject, and one of the questions we have prepared is to have a short discussion among yourself on the science on board, and first of all, in particular, relation and ties you have with the scientists. So could you elaborate a little bit what sort of dialogue you have in the preparation of your flight, and then the experience you have in communicating with the scientists, because you actually activate some of their experiment, or you are there to actually being their brain and hands for a very important experiment they prepared for many years. Could you maybe start, and Leo, maybe as you were part of that recently?
Of course, as a long-duration crew member, you are prepared to perform several experiments on board, so you have usually a lot of science involved, and so of course it's hard to get ties with all the scientists preparing all the experiments. But the main moments where we are actually able to interact with the scientists is during the training, when we have some training sessions on different experiments. Of course, quite often we have the PIs, not the payload investigators, which are participating to some of the sessions. And of course, after the flight, we spend some time also for debriefing with them. Unfortunately, as astronauts, we are mainly operators, I would say. So we are not too much involved in the science itself. So we are actually setting up the experiments on board. We are operating them. Sometimes we are subjects, but we don't spend too much time studying the science itself, of course. And this is sometimes a little bit concerning, because we have questions, for instance, during PR events or PAO teleconference with the ground about the science, and we are not always very well prepared to answer to the pure science questions. But of course we end up knowing most of the scientists which are taking part to the research on board.
So I guess you do have sometimes a difficulty to answer that question that comes all the time from the media. What are the major scientific achievements which were performed on board of the station? How do you get around that question, Jean-Francois, your own way?
I had two intensive scientific missions. Science intensive. The first one was dedicated to planet Earth, Atlas 3. So we got a lot of briefings about the usefulness of those experiments. Essentially a different kind of sounders measuring concentration of 200 different kind of gases in the atmosphere. And the second flight we had to Mir, we had a lot of scientific experiments, especially biological experiment. And it is important for us to understand the purpose of the science, the interest of the science, although we don't do science in space, like Leopold said. And when we have good briefings beforehand, we are more conscious of how important is this task versus this other task. We need to know what is important, where we cannot fail at all, and where we can recover if we miss one move, one task once, then we can redo it. But it is very important to know what is important to not miss and succeed the first time.
And what would you say the most difficult science experiment was, in terms, whether you understood it or not, in terms of operation? The most difficult and then the most fun experiment in terms of science, if you have any?
I can answer. The most fun, for me anyway, we had an experiment called Spheres, and let's see, during the very first ever live HD downlink from space, I could not remember what Spheres stood for, so I'm not about to try now. But basically, they're small satellites about the size of a volleyball, size and shape of a volleyball, that we let free fly inside the cabin, and basically it was a technology demonstration to look at flight control algorithms to make these things fly in different formations, actually rendezvous and dock with each other, separate. It was fascinating to watch. The idea is someday perhaps we could use an experiment like that to have a satellite fly around the external surface of the station or maybe the space shuttle to have a look at the inspection of the thermal protection system. That's probably not going to happen in the lifetime of the shuttle, but that's the application. But from a pure fun standpoint, it was fascinating to just watch these things hover around. I can tell you the one that was least favorite was having to take your own blood samples about once a month. I think I had to do it 6 or 7 times, and all but once it was just fine, and the other time, bruises all over my forearms.
When a whole country like Japan is looking at the launch of Kibo, which was very successful recently, and your dream is to sleep within the Kibo, how do you look at the relationship with the scientists in Japan to prepare yourself to be the sort of ambassador of these people on board of the science laboratory, being one of the biggest ever in space?
Okay. Well, I'd like to make the kind of trust relationship between the scientists and us, and plus I'd like to understand the meaning of the science and the significance of the experiments. And I'd like to be a kind of speaker to the public how important these experiments are. That's my objectives.
Now, how about you, Sergei? Over the 6 slides, do you feel very big differences in focus on science objectives from one mission to the other?
That's what I wanted to say, that missions are different from each other, and every mission have own emphasis on different experiments. Talking about most interesting, it's difficult to talk about most interesting, most difficult, because sometimes it's difficult even to compare. One of most interesting experiments I had on Mir station was assembly of big truss. It was very interesting technology to assemble this truss with special alloy with a memory. So we hit special elements of this truss, and it make permanent connection one pieces to another. And we built pretty big truss, about 14 meters at that time. So that was that involved several EVAs. So that was pretty challenging activity at that point. And assembly itself was very interesting. So everything worked well, and I recall good memory from these experiments. If we talk about missions like Expedition 1 on International Space Station, I think the biggest experiment was to fit all pieces together, to activate the station and to see that pieces built in different countries by different groups of engineers will work together, and we will able to activate it. So, as I said, experiments are different from mission to mission.
I think some fun experiments, and I had on my first and second space flight, is when you have to care about animals without doing anything bad to them, just to observe, to ensure they are right. We had the pregnant rats on my first flight, and on my second space flight we had the tadpoles, you know, baby frogs, and we had cockroaches, wasps, and you know, it's just observing them, taking pictures, ensuring they are fed properly, etc. And it's fun, and it's not too difficult.
And maybe returning back to the first question, beginning of the questions about relationship with the scientific community, I can say that during long training on the ground, and then during mission, when you talk to scientists during flight, you become part of their team. And usually my experience is that even after flight, when you meet these people, you feel that this is a group of your friends, you were working together, and really you develop not only scientific partnership, but also personal relationships.